I'm audible. Yep. Yep. I'm audible. Yep. Yep. I'm
So
audible.
we are live on kick.com, Circus Ahmed. And so we changed the title. So we made it a little bigger because I see that not many people care about what I do or whatever. I can just teach anyways. We are live. Look, I'll just show you guys actually. So we are live. So that's not going to be Python now, it's going to be C embedded C programming. We are live. Make Valentina Gomez Noriega proud. All right, let us begin. We're going to do embedded C. We were here, and I don't know if you can see my screen. Yeah, we were here. Oh shit, I deleted Visual Studio Code. Okay, I need to download Visual Studio Code again then. Download Visual. Okay, I need to also download this. Okay, how to download C and like how can I program C and whatever? So sorry, I'm so sorry. Me download C again. Fortunately, deleted them since I thought I could download Kali Linux. No. All right. Just download. No, I downloaded C before. I downloaded C before, but I deleted again because I thought that I could download Kali Linux. So I deleted C, I deleted Python, I deleted Visual Studio Code, I deleted almost everything, bro. Everything. I was stupid because I thought that I could easily download Kali. Because last time I did download Kali Linux, and so I thought, you know what, it's going to be easy. Nope, it wasn't easy. I'm just going to also write in here. Programming embedded C for missile AI model trajectory. All right, finish. I'm no Neymar, man. I am not Neymar. Yeah. I think I also, let's see, include stdio h. Uh, let's run this. Let's run this. I don't think I'll be able to run this though. I don't think I'll be able to run this. Let's do that. I don't think I'll be able to run this. I have a very high good feeling that I won't be able to run this. And the reason I won't be able to run this is because I deleted the so you can install an extension for C because I deleted the what do you call the terminal that actually allows the execution for C, which it didn't let me. So which means because I thought that like I said, I thought that I could um, easily download Kali Linux. So yeah, I get these three errors. And I need to compile all those too. I think I need to download this MSYS2, right? It is really hot, like really hot. Like it's 10 degrees. Like at night, today daytime, during the daytime, it was 21 degrees. Uh, okay, I think I need to download few stuff, right? Like I have a feeling I need to download few stuff. How do I download them? I think I need to download few stuff. I no, I deleted everything. I deleted everything. Okay, GCC version. So GCC. I don't think I will have GCC anymore because yeah. So because I deleted GCC. Again, I deleted GCC because I thought that I could easily download Kali Linux, and I'm gonna do C on Kali Linux. Doesn't matter. Doesn't matter. Yeah, it's not recognized. It doesn't matter. No, I deleted. Like I said, I deleted GCC. I deleted GCC and MSYS2. I deleted them and download. Diferenciado. Diferenciado. Next, 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 next. It is really hot. How much is it to travel from uh, Canada to Colombia? Not Bogota. Not Bogota. Actually, St. John to Colombia. Cali, 1,458. Medellin, Bogota. I'll travel to Cali. Yeah, Cali. Yeah, Cali. But then how do you travel? Okay, let's see. Okay, St. John's to Cali. Cali, Colombia. We'll go September. Because September is the cheapest. September 1 week. Yeah, now it's going to show $752, but let September come. It's two people. Let September come. Oh shit, it's actually cheaper to, I mean, much more expensive to have two tickets. But again, let September come. My plan is to go to Cali. I tried to ask Valentina, but again, I don't think she's gonna help. Exactly, right? Interesting, blaming the Sikhs, but you know what you would have done if he was Muslim. It doesn't take. She most likely has a partner from UK. Most likely, I'm not sure. Most likely. She's beautiful. She's beautiful. Yeah, she's beautiful. My God. Anyways, finish. Let's run it. And what am I supposed to run here? What am I supposed to? Okay. I pretty much knew it. Pretty much knew it. I am going to get a notification. I fucking knew it. I fucking knew it. It does. Okay, what am I supposed to write here? Pac-Man. Oh, you can't copy this? Can you copy? Oh, right. Pac-Man is min GW ECRT X8664 GCC. Okay, it says target not found. What does it say? It says target not found. It says target not found and this. And she has a lover from UK. Pac-Man, 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 fuck. Pac-Man SYU. So Pac-Man SYU. Yep. It just closed. I don't know if it installed or not. So it installed and then closed. I need to cut my hair. GCC version. It's still not recognized. It is still not recognized. Okay, I have to. Okay, MSYS CRT64 GCC per. Oh no, GCC version. So GCC command not found. Yes, it says GCC command not found. Pacman SY. So Pacman SY. It is her concern. It's the kid. It is her concern. Voices are not being heard. If a non white speaks up, it bridges what's wrong and what's right. Majority don't want to do that. All right, MSYS, it shows it's up to date. It shows it is up to date. Pac-Man SSGCC. So Pac-Man SSGCC. Okay, it's not many things. It's quite a lot of stuff. I hate what how much hate she gets. I hate it. But then, yeah, like if you are the one um supporting her, like you can also get you know, blocked by her because if if a Muslim supports her, it's kind of like a bad thing. It ruins her image. W64, UCRT, X86, 64, GCC. But yeah, you don't know when to compliment or insult her. You cannot insult her because I can't insult her because she made me someone. I cannot. It's a disrespect. It'll be a huge disrespect. I'm not that kind of person who I'm just going to disrespect a woman just because she hates Muslims. Nope. Not I'm not going to do that. She can do anything she wants with my religion. I'm not going to say a word to her. GCC version. All right, 16.1.0. Now, yeah, so include stdio.h int. Yeah, we're just going to run all that shit. Okay, I still do get an error though. Run the file. Um, I don't know. It still shows an error. Okay, now it keeps saying open the folder, open the folder, open the folder, open the folder. So I'm not able to run because it keeps saying open the folder. You please open a folder. Now I am not able to. Okay, wait. I think is it because let's actually save it. Save as main program. Let's say that main program. Okay. So Windows launch. So the workspace, so they said that please open a folder. Variable workspace folder cannot be resolved. They said variable workspace folder cannot be resolved. Please open a folder. It's her issue. Yeah, it says that. Uh, file open. Oh, okay. File open folder. Yeah, we're gonna open this. Nice. So include stdio.h int main. I don't know. Print return 0. The executable you want to debug does not exist yet. So that's the error I get. You need to what? So I just did it. Oh, I didn't save it. Okay. Hello main.c. Okay, so it does not exist. So now it says the launch program does not exist. Let me look at if I need to install anything else. Well, let's install that. So now it says launch program does not exist. So now it says launch program does not exist. Open JSON file. I do. Yeah. I have it. Okay, you know what? Let me refresh it. So I have it labeled as main program. So I have it labeled as main program. All right, so No, main program. Yeah, main program dot c. Yeah, main program and main program dot c. So main program, and then it shows C source file. So it shows main program dot c. But obviously, when you save it, it says main program, and it is a C source file. GCC main program dot c or main program. Okay. So GCC what? Main program dot c or main program. So there is no such file. Okay, GCC hello main dot c or hello main. I did that. So this is what I did. So I don't know if you can see it. That's what I did. So hello main dot e. Why should I type that? Okay, so I have to write dot hello main. Okay, it is working. Cool stuff. All right, so let's begin. Let us fucking begin. So we will be programming with E. So here, we're gonna finish off. So we're gonna start building. Me 30 minutes. We're gonna begin building. I may not need the iPad today. It is so hot that I feel like puking, man. It is very hot. I think what I'm going to do from now on is that once I wash the clothes, like I wash clothes every day. Every day I wash clothes. And I'm just going to leave it here so that it automatically cools. What will be the weather like tomorrow? Weather St. John's. Yes, I'm in St. John's. Oh, 12 degrees. Thursday is 30 degrees. Fuck. Whoa. We are doomed. 26 degrees. Okay, please let it rain. Please. That's pretty good. Pretty good. Because, man, it is. And like here, it's like very low. The ground is like extremely low. And so you won't be able to breathe properly. Like, it is very low here. So like it is very, very low. It is very low in here. Like let's say for example, like if you have like you can breathe properly, but then like at the same time it's also hilly. It's very hilly. So like if it's very hot in here, like if you work out here, like in this province in St. John's, if you like work out in Newfoundland, if you like work out or do some running or do some exercise, you burn calories. You can come here and lose weight. Like if you stay here for 1 month, and if you go back to a different province or a different state again, you will lose weight. I'm telling you, you will lose weight. This province is good for weight loss. It is so good. Like you can, because obviously during the summer, like you won't eat as much because you won't get hungry very quickly. But my God, if you work out here, like or play football and shit like that, you will lose weight. You will lose weight. People do this like, oh, winter, like They do this winter arc or stuff like that. You don't have to do winter arc. It's bullshit. In this province, there's no winter arc. Winter arc here is bullshit. Because at the end of the day, during the summer, like if you try to do winter arc or you're going to try to lose weight during the winter, and then if you want your summer body, right, it's kind of like you're almost killing yourself. Because during the summer, you're going to lose weight anyways. Anyways, you're going to lose weight. It doesn't matter. It really doesn't matter. You're going to lose weight in the summer anyways because you won't eat much. It's so hot in here. If it gets like 26 degrees, 30 degrees, and like obviously it's hilly area, right? So you won't be able to breathe as much. It's literally hilly. Like I have like hills literally beside me. Like I have hills beside me. I'm just going to close that. Like I can see Europe, the Europe continent. Like I don't know if you guys are watching this, but I can see Europe, like England, because the closest from here I can go to is England, Ireland, Netherlands, France. Like literally beside me, like literally beside me. So let's say, for example, if I have a boat, and let's say I got like okay, so I have a boat, I have all the papers, I have all the legislations and stuff like that. I don't have to take a plane. I can literally take a. It's literally 4 hours by boat. 4 hours by boat. I don't know because if you take a plane from here, you have to go all the way to St. John's International Airport, wait for the plane, then take the plane. Plane is like what 2 hours? It's 2 hours by plane. It's not far. Like literally, it's only 4 hours by boat. 4 hours. So like 4 hours later, I'm gonna reach England. The city that I am in, the city that I'm in, it's you'll have Irish people, you'll have English people, you'll have Newfoundland people. Like Ireland and Newfoundland, like they're like pretty similar. Like in a sense, they're pretty similar actually. Newfoundland is goat. Like I love Newfoundland. Like it's amazing. It's amazing that people come here like they take advantage of. Oh, I'm in Newfoundland. It's very easy to get citizenship, but I don't think they understand history. You need to understand history. You can't just come here and like know nothing about this province. Like that's pretty bullshit. I feel sorry for the people like who has to deal with these kind of people who know nothing about Newfoundland. You must know. Like I want to know because like after the 9/11, this province was like the cornerstone. Like we have many Americans lived in Gander. So there's a city called Gander. They resided there. After the 9/11, they moved to Newfoundland. Like this province is literally the hub where if they couldn't travel to America, they came here in Newfoundland. Newfoundland was the hub spot because that was the closest. It was the closest they can travel to. So there were like 290 planes. 290 planes. Everyone landed in Gander. So we can show it. We can see actually. Gander 9/11 Memorial. So the closest, so 38 diverted flights. So they were like 209, 200, 300, 400 planes came in. So Gander was the closest they can reach. Gander International Airport. Like everyone was here. Everyone was here. So the fact that many people who come here they don't understand this province is pretty shit. Anyways, one image at a time, and I think I'm gonna do this. Let's do it one image at a time, slowly, step by step. Let's build the AI model. Come on. All right, stop. Slowly, slowly, slowly. Calm down, calm down. So they said that x is equal to x plus 1, so it's the same as plus plus x or x plus plus. So at first it looks boring. So adaptive guidance system runs every 100 milliseconds. So cycle 1, cycle 2, cycle 3, cycle 4. So you're going to have cycle 2 being cycle 1 plus 100 milliseconds, right? So every cycle is going to read the sensor, it's going to estimate the state, it's going to update the model, it's going to solve for MPC, and it's going to send the steering command. Yeah, the and I need to also learn bash. So I'm not going to click run. I'm going to actually write it in bash. The computer might do a little, okay, so include stdio.h um, while one. So cycle one cycle will add, and you're going to estimate the state. Actually, let's create a function. Actually, I have I think I have a book that, let's see, which actually one question. Which book is the closest to missile manufacturing, but in C, but doesn't do the programming, doesn't do the. Actually, wait, I have the simulation book. Which book is the closest? Which book is the closest to missile engineering that doesn't do the program? That doesn't do the program. That doesn't do the program. But you know, whenever you read it, it closely correlates to embedded C programming. Okay, give me one for now. Give me one. Modern missile guidance. Okay, give me one book. Give me one book. Missile guidance and control systems. This is for C programming, a theory book. Anything? Do I have to know anything from here? So rockets have been used in the earliest AD 1232 Chinese. Okay, whatever. I think these are all history, right? Okay, these are all history. So how would we program that? Because I mean, you need to learn the maths, right? This will be for chapter 3. This will be for chapter 3. The Python will be for chapter 2. MATLAB will be for chapter 4. So technically, I'm doing chapter um, 1, 2, no, 2, 3, and 4 all in one. How many chapter 2s are there? Okay, let's just finish chapter 2.1. When does 2.2 finish? I mean 2.1 finish? Okay, so we are finishing. I'm telling you, everything will be good. Everything will be good. I'm positive. I'm positive. Uh, That's the yaw moment. If you're confused what that is, that's the yaw moment. All right. So one by one, what is going on, and let's do build the you know model using embedded. Okay. Oh. Okay. Go slowly. Okay. So imagine a missile is flying. The missile will see forward, right, down, but the Earth will see north, east, down. So the same velocity can look different depending on who is looking at what. And so suppose the missile is moving 100 meter per second forward. Inside the missile, the velocity will be 100, 0, 0. Obviously, because if you have a vector that has the velocity vector in terms of x, y, and z, obviously you're going to have 100-meter forward. So you're going to have north, south, east, and down. North, east, down. And north is 100 meter per second, east is 0, and down is 0. And because the missile only knows forward, right, and down, but the Earth will see 70, 70, 0, meaning you're going to have 70, 70, 0. The velocity did not change, only the coordinate system changed. And why cannot I charge my fucking iPad? So what this means, the physical vector is the same. The numbers used to describe may change. And so suppose the missile velocity is 380 meter per second, the missile will say 300, 300, 300. Right is 0 and down is 0. But the Earth might say north is 250. Um, what do you mean Earth may see? So let's create the first missile. So type DF structure. Okay, so how would you program that? How would you no type DF structure, float of x, float of y, float of z, and then vector 3. Now create the velocity. You're gonna write type DF DEF structure, and then we're going to create three functions. Say float x, float y, and float z. Nope, this will be vectors. And then vectors, velocity. Oh, now I understand. So velocity dot x will be 300, velocity dot y will be 0, velocity, I think, dot z 0. What's the mistake? What's the mistake? Expected. Uh, did it quick fix it? Okay. Okay. So we created. Come again. What does this mean? So you have the forward speed. Okay. Why isn't this charging? That's so stupid. We have the forward speed, we have the right speed, we have the down speed. This way, this way. So this is literally image one. The book says that a vector has three components. In embedded C, vector 3 velocity, in my case, vectors, is exactly these three components. The vector has three components. You have velocity in the x-axis, velocity in the y-axis, velocity in the z-axis. So now your flight computer will eventually store, why will it store position, velocity, and acceleration? Okay, before moving to the transformation matrix, make sure the ID is clear. So vector simply is numbers such as velocity, and different coordinate systems define the same quantity but different values for the different represent. So different values, different representation, but on that same Venn diagram. Yeah, got it. Got it. Okay, let's try that. Let's try it. Let's run it. Let's run it. Um, let's run it. Let's see what happens. GCC hello main dot c o hello main. Hello main. What do you mean? Oh, come on, it was working, man. Ugh, hate this shit. Okay, save. GCC. What? Okay, what? Dude, I can't. What is going on? What is going on? Okay, hello main. GCC hello main dot c o. Yeah, I'm going to run the program using bash now. You can hear me, right? Hello main. I'm going to run using bash now. I am actually going to learn using bash because running here is like that's too kiddish. I need to go old school. We got the values, so that's how you print the values. So dot 2f means you're going to have two decimal places, two decimal points, two decimal points, and then velocity of x, velocity of y, velocity of z, and then you're going to return to 0. Let's move to image 2. Move to image 2. I'm going to leave this iPad somewhere else. It's getting kind of annoying. Oh man, fuck, I need the iPad. For fuck's sake, man. This shit. We're just going to, I'm going to move the mouse here. I'm sorry, I'm so sorry. Move the mouse here. I'm going to move the iPad charger here. Plug in the iPad. All right. Now we reach the first piece of math that appear in almost every missile guidance system, aircraft flight computer, drone autopilot, IMU navigation system, Kalman filter, and MPC control. So the book introduces gamma of I and J. So he's going to say gamma of I and J, and then it's going to show gamma of 1, 1, gamma of 1. Wait a here. So gamma of 1, 1, gamma of 1, 2, gamma of 1, 3, and so on and so forth. And of the 9 quantities, only 3 are independent since there are 6 independent relations between them. 3 are independent since there are 6 independent relations between them. What do you mean by that? You said there are 3 independent. So each frame, so suppose you have two coordinate system. You have a north, you have an east, and you have down. The missile will frame as forward, right, and down. The missile measures the velocity, meaning 300 meter per second forward, 0 meter per second right, and 0 meter per second down. The Earth will not understand forward, right, down. Earth will only understand north, east, and down. So we need a translator. One question before that, what is going on? So the translator is gamma of ing. So this is okay, makes sense. The only reason we need this gamma matrix, the only reason you actually need a gamma matrix is because whenever you want to make sure that it's able to detect where the position of the rocket is, the position of the rocket will be measured based on north south down or northeast down or northeast south, maybe like something like that. But it doesn't understand forward, upward, down. Earth will not understand that. And because Earth will not understand that, meaning your sensor, even though your sensor you're gonna program saying up, forward, up, down, whatever, you must make sure that the missile is not on your, like what I mean by that is missile will be in the air, and because missile will be in the air, the even if you wait to do the programming and stuff like that, at the end of the day it is Earth who's trying to control the position of the rocket, because yes, you can program, yes, you can control the trajectory of the rocket, but if the Earth's gravity plays a role, how much you control it doesn't matter, right? Because at the end of you can't control the weight of the rocket, right? You cannot control the weight of the rocket because the weight of the rocket is pulling the missile, right? And can you change the fact that it's pulling the missile through programming? I don't think so. It's like saying that you're going to control the rotation of the earth through programming. I don't think so, right? Same thing. That's like subconsciously does the work. Like earth subconsciously pulls the missile downwards. But what you can control is the weight moves forward, the weight moves left, whether it's pitching down. You can control. It is going to go down. That's something human. Like you have to always believe that it is always going to go down, but you can control how much it can move forward, you can control how much it goes down, you can control how much it can move forward because the drag force is also coming in. You can also control how much it moves sideways because at the end of the day there will be wind uncertainty, right? Those are subconscious, but you can control how much it can move. But to do that, you need to have a matrix because again, a computer does not understand English. A computer will only understand zeros and ones. It only understand numbers. So you need to make sure that you convert it into numbers. So think of as missile coordinates, transformation matrix, then the Earth coordinates, and y 3 by 3 because they have x, y, and z. So 3 by 3. So forward will be north, right will be east, down will be down. So technically, you're going to have three independent variables because six of those independent variables correlate to three of those. So six of the values. So if I have 1 1, 1 2 is based on 1 1. So it's still in the one side, right? 1 3 is still on that one side. 2 1 is not independent. 2 is independent. 2 3 is not. 2 1, so it's like diagonal. It's always diagonal. 1 1 2 2 3 3. Rest of them, they correlate. These six values are also independent, but they closely correlate to the three independent variables. What does the book say? So if I have gamma square of 1 1, gamma square of 1 2, gamma square of 1 3, that's equal to 1. It's a way of saying each axis must remain a unit vector. So it cannot suddenly become length as 5 or length as 10. Axis only rotates, so they do not stretch. So therefore length will be 1. Although I still do not understand one thing clearly, which ones are the three independent variables and which ones are the six independent variables that play a role in the three independent variables. One thing I don't understand is that which one are the three independent variables and which ones are the six independent variables that play a role based on the three independent variables. people are watching. Cool. Anyways, so the book says there are quantities. Okay, so inside the matrix, okay, this fucking iPad, man, I swear to God, it doesn't even fucking charge. What? So is this damaged or what? I don't know if it's damaged. Anyways, no, it's not damaged. It's working. I don't know, man. I swear I don't know. Anyway, so inside the matrix, you can have gamma 1 1, gamma 1 2, gamma 1 3, 2 1, 2 2 2 3 3 1 3 2 3 3. So initially, it looked like these would be nine unknowns. And the only reason these are nine unknowns is because, they are variable. Each of those quantity that are inside the matrix is held as a variable. So I don't know what they represent. I mean, yeah, you can say gamma 1 1 forward, gamma 2 2 east, gamma 2 3 3 down. You said that, but the only reason you said that is because you stated it. But before stating, so let's say you looked at the matrix, you saw the matrix. Well, I don't know what this is. And why not nine independent variable? Because the axis must remain unit length and perpendicular. So in one way or another, it correlates to something. So let's say, for example, if I look at the top row, gamma 1 1, gamma 1 2, gamma 1 3, the length must be 1. So it's like a probability, right? The length of it must be 1. So I mean, you can. So I don't know if you have done augmented matrix. I don't know if you have, it's linear algebra, right? If you have done augmented matrix, or if you have done reduced row echelon form or whatever, you know that on the first two rows, like the first two columns, you cannot have one. So you're gonna make sure you're gonna do all those man, that was like a long time ago. You're gonna do all those substitution and then break down the matrix. So if you have like, I don't know, 4 and 8, for example, so what you're going to do is you're gonna divide it by 4, and then you're gonna change the entire matrix by 4, and then you're gonna change the bottom or the complete bottom matrix by 4, and you want to make sure that the first two columns are 0, leaving the top as whatever the value it is at first, right? And then from the second column, you're gonna make sure that the top value, like the top matrix, in the middle there is a value, and the rest of them are 0 or whatever the closest value will be. And obviously here is going to be whatever the closest value is, or in most cases it's going to be 0. So that's a reduced I mean, not a reduced row, it will be the row echelon form. And then all the way at the last, it's going to be a value. So if you have done x, y, and z, so it's kind of like x will be a value, y will be a value, z will be a value, right? Similar to that. So you need to make sure that you need to, in a sense, that you need to simplify to a point where whatever the values you have on the diagonal, it closely correlates to what the x value will be, what the y value will be, what the z value will be, right? So you want to make sure that, and all those six values that he mentioned. So if you look at the book, it says that only three are independent. So in most cases, it's going to be 1, 1, 2, 2, and 3, 3. And since there are six independent relations between them, so you can have 1, 2, and 1, 3. That's one that correlates to 1, 1. You can have 2, 1, and 2, 3 that correlates to 2, 2, because it should be diagonal. You need to have values in diagonal. So if I were to say 300, 0, and 0, then I'm going to have 300 for 1, 1, 0 for 2, 2, 0 for 3, 3. But obviously, in reality, you're not going to have that. First constraint. So if I look at the first row, then I'm going to have 1, 1, 1, 2, 1, 3. That's going to add up to 1. And then 2, 1, 2, 2, 2, 3. That's going to add up to 1. If I square that, and 3, 1, 3, 2, 3, 3, that's going to add up to 1. Each axis length is 1. So forward length is 1. Right length is 1. Down length is 1. And I cannot switch on the iPad. Yeah. Let me see if I can. It's been quite a while. Okay. So what do they physically mean? So each axis has length. So forward axis will be 1, right axis length will be 1, and down axis length will be 1. Oh. And then second constraint, the axis must be perpendicular. You mean the columns? Columns, right? The columns, right? I'm confused. Second constraint set. Which one's the second constraint set? Which one's the first constraint set? I understood. First constraint set, I understood. Which one is the second constraint set? I don't understand, man. Is this thing damaged or what? Holy fuck, man. Wait, it is working, right? Yeah, it is working. I can literally feel it. It is working. Oh God, man. Fuck's sake. Okay, now I hope it works. It's gonna take some time now. Anyways, let's continue. Let's program it. Why not we program it? Let's program it. Hmm. Both. What? No, 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 no. Oh, come on. What did we learn this time? The first constraint set and the second constraint set. The first constraint set and the second constraint set. Let's program both of them, dude. It is hot, man. I don't understand how the fuck will I survive here, man. Okay, we have a rotational matrix, so gamma 1 1. Oh, second constraint is rho 1 times rho 2. Rho 1 times rho 2 is 0. Rho 1 times rho 3 is 0. Rho 2 times rho 3 is 0. Do I write int main again? I don't think I have to write int main again, right? So if I were to program in correlation to this here, how would I continue with this? I know I can't write int main again. How would I continue with this? This means you okay, we can do that. Vectors position 0.0f, 0.0f, and 100.0f. And then int main, actually we can do that. We can do that. I'm just going to put another enter here. Then print position, print. Printf position, and then we can write x being percentage 2f, position of 2f, 2f, 2f. So it'll be in two decimal place for position x, y, and z. Yeah. Yes. And then we return. Let's run it. Let's run it. So gcc hello main or hello main.c. So you're gonna open the file, and then so the file will enter, and you're gonna run the program. So we will run the program. and then dot hello me. All right, we only have velocity. That's the thing. Why am I only getting velocity? Did I make a mistake? Oh, no. I have am I making a mistake, or is it because now let's run it. Hello me. Okay, I need to okay, G okay, fine. Hello main dot C O hello main, and then hello main. That's the thing. I'm only getting velocity. Why am I not able to get position? Is it because you have two variables for the same thing? Let's try one thing. Float A, float B, float C. Let's try. Let's say A, B, let's say C. And I think these will be will be A. Yes. Now let's run it. GCC hello main O hello main. Oh, GCC hello main dot C O hello main. Then hello main. Okay, we only get velocity. Okay, I saved it. Look, I saved it. I'm proving it to you. Look, save. And GCC hello main dot C O hello main hello main. All right, now it's working. Fuck yeah. Okay, now wow, how do I? Okay, I just did the program. Yeah, but it doesn't. No, but I don't think you're trying to understand it. How do I write the? No, I want to do the matrix. Like, how do you do the matrix for it? Come on. How do I program the matrix for it for my abstract and correlate or correlate into a real life perspective, like correlate for the real life operation. Come on, man. And this iPad doesn't work at all. Okay, okay, okay. Missile heading is 45 degrees. What of 45 degrees? Output 0.707. Oh, both sine and cosine. Missile is heading 40. Okay, I don't understand the matrix part. I don't understand the matrix part. How do you get the values? Wait. 1 minute, 1 minute, one question. How do you even get the values? How do you even get the values? Like, I'm confused. I'm confused. How do you get the values? Because you said that okay, it moves at 45 degrees. Who even detects that? Okay, I mean, you said that it moves at 45 degrees, whatever. But who detects that? Wait, yeah, actually, who detects that? Python doesn't detect that. Does MATLAB do it? Who detects that? Like, are we going to use a different programming language to detect the angle of the missile, or are we going to use the same programming language? Programming language. Because how do you even get the values? No, I know. Obviously, it's going to have sensors. Obviously. So then let's create those functions, right? Are we making a mistake? Yeah, let's then we should have that. Okay, then one question. I'm so sorry that if I'm talking too much, but someone should be getting the sensor measurements. Let's not suppose. Let's not use examples and say suppose. This is a big thing. This is a big thing. Please, we're not kids anymore. We are not kids. Let's not use suppose and get straight to the point. It is not productive. How did we even get the matrix though? Okay, so okay, how would you calculate the matrix then? Okay, wait. One question. Okay, wait. Shut up. Oh God, man. Dude, this thing is fucking annoying. How do they even get the matrix? That's what my question is. I know there's a matrix. Okay, you can hear me, right? Okay, I know there is a matrix. They literally explain there is a matrix. Okay, let's go back to this section here, the coordinate system. Let's go back to this section here. Let's go to this section here because my iPad doesn't work. So, do they explain, like, if I were to correlate this information to my program, to my embedded program, how would I get the measurement? How would I get the matrix values? How would I get the actual matrix values? Yeah, how would I? The matrix, obviously they're not arbitrary numbers. Who the fuck even said that? I-axis in one frame, the cosine of the angle 1 is the cosine of angle between x of b and x of e. Now, what is x of b and what is x of e? Okay. Fuck this iPad, man. For fuck's sake, man. This shit, man. It's fucking gay. Okay, doesn't this work? Okay, you know what? Um, I don't think this works anymore. I have a feeling that this doesn't work anymore. Okay, anyways, how do you get the maths? So which means you need a math to actually be able to calculate this matrix, right? So you need the maths to be able to equate this matrix. And then when you input that, okay, so isn't there a math for it then? So isn't there a maths for it then? The book says this is the so we need I'm just going to write type df, type df structure, float roll, float pitch, and float yaw. Float yaw. And we're gonna call them altitude. Nope. They'll be in angles. Roll, there'll be an angle. Pitch, there'll be an angle. Yaw, there'll be an angle. So once unknown, that is matrix is computed, not measured. So the page later will show the Euler angle transformation. This fucking iPad, man, I swear. The book eventually did. Okay, they did. I don't see it. Wait, then what does 2.1.1 explain? 2.1.1 is just a summary of everything. Now, what does 2.1.2 explain? Okay, out of all the okay, where's the Euler angle? Oh God, where is the Euler angle there? Then what's with 2.1.2? Where's 2.1.4? So they say that there are three commonly used methods for expressing the orientation of three axis coordinate system. So you're going to use the Euler angle, directional cosines, quaternions. We're going to use the Euler roll, pitch, and yaw. So there, its strengths lie in a relatively simple mechanization and digital computer simulation of vehicles, missile or aircraft dynamics. Another beneficial aspect of this technique is that the Euler angle rates and Euler angles have easily interpreted physical significance. All right, let us do the Euler angle then. So you're gonna get the so we're gonna write this is cosine sine. So cosine for roll and float cosine for roll will be cosine of roll and then float sine of roll will be sine of roll and we're gonna do the same for cosine of pitch, sine of pitch, and we're gonna do for yaw. Now we do have roll, we do have pitch, we do have yaw. This will be altitude dot roll. Yes, it'll be altitude dot roll, altitude dot pitch, altitude dot yaw. And would this also be altitude? Quick fix. Okay, let's see. Oh shit. Okay, keep, keep, keep. So what did you do? Okay, you can hear me, right? And this fucking iPad doesn't work. Anyways, what will okay? We got the altitude for roll. Attitude? What the fuck is Oh, it's altitude. God fucking damn it, man. Okay, we got the altitude for roll angles for both cosine and sine. We got the altitude for pitch angle for both cosine and sine. We got the yaw altitude angle for both cosine and sine. And so now what we're going to do is we're going to get the position, we're going to get the velocity, we're going to get the orientation. Orientation being the angle itself. And if I now let's run it. Let's save it first. Save it. Save it. Look, I saved it. Save. I'm gonna write gcc hello main dot c o hello main and hello main. Right. got the angle. We got the angle for cosine and sine. However, this is only considering the fact that all of them are in zeros, correct? All of them are in. Okay, so how do I fix this code here? Then how do I fix this code? Wait, oh man, wait, wait. Nothing's making sense. I got the float angles for my position and velocity. I got the float angles for my cosine and sine for roll, pitch, and yaw angles. I output the values. My main thing is that I won't know what values exist, correct? I will not know what values will be entering into this altitude because this means that I'm pretty much, you know, inputting the values, correct? Okay, wait. This, no, I know, I understood. The only reason, how will I program where if like if any values that enter is going to do the same thing. So I understood this program. First of all, I understood this program. Firstly, wait. I understood this program. Wait, I understood this program. Don't change it. However, for the altitude, and I input the values already, altitude, and then I input the values already, put the already given values. I won't have those values. Instead, I will have values that the sensor will measure, that the sensor will measure, and that the same goes for position and velocity, and the same oh shit, and the same goes for position and velocity. How do I, how do I? So I need an equation, right? Wait, firstly, do I need an equation for it? Do I need a mathematical equation for math equation for each of position, velocity, and orientation, that with that maths they're going to figure out, okay, this is the velocity that measures each of those. Okay, so I cannot just randomly import values. I need an equation for it because this book, I understand this book is teaching, but you need an equation for position. You need an equation because you want to train the model. Your main aspect that is that you want to train the model. But training the model is done by Python, not C, right? Then do I need to use another programming language, or can I use the same programming language? Do I need another programming language, or can I use and do the maths inside the same programming language? No, I know that that'll work. Actually, yeah, that'll work. Why am I focused on other programming language if I can do the maths inside the C? Then I need Euler equation, right? Euler is the closest because I mean, wouldn't Euler equation or Euler integration be the closest when it comes to training the model? And then what we can do is every, because the abstract literally says is, I mean, because abstract says under millisecond, we can probably put a set differentiated value, maybe 90 or 95 max, and perform Euler integration from it. And reason is integration is because it's not like in boxes. So if you think about it, it's not going to go straight where you can easily draw boxes. It's going to go straight, then up, then down, whatever. So if I were to break them down, obviously they will not be discrete. They're going to be continuous. So pretty much you need to use Euler integration from it. Can we do that? If yes, can we also import this equation? If not, if not, what would the best approach be? Ah, you need the adaptive guidance algorithm. I don't have that. Wait, I need that then. I'll just come back. Okay, they are not the same. Then what was I doing? No, I know. Obviously. It's not the Euler integration that does the 100. Euler integration will only update the values. Euler integration is only going to update the values. That's it. But the 100 millisecond or under 100 millisecond, like, it's only going to read by modeling the sensors and stuff. That I know. But if, man, I'm so confused. Okay, then let's. Then do I need an? Oh man, I'm so scared, man. I swear, I'm so scared. What do I do? So do I need? So do I need is another book that has the adaptive guidance algorithm book? Adaptive guidance algorithm. Don't I have that book? Modern Missile Guidance. This is the book. Yeah, yeah. I have Modern Missile Guidance. This is the book. Missile Guidance and Control Systems. I literally have that. Oh wait, wait. We have that. No, we have the math. Actually, we do have the maths. We do have the maths. We do have the maths. Wait, we do have the maths, but it's in the later sections of chapter two. We are not there yet. We do have the maths. Okay, then we need to move fucking fast. Now we have maths. Okay, so what is going on here then? Actually, there are maths in the tensors. Let's look at the tensors actually. Okay, let him finish it. Okay, so um, what would the general equation be here? What would the I'm sorry about the noise. I swear to God. What so based on the tensors will have the general equation. Then how would we calculate the tensors for these matrices? I think the equation does exist, right? Any tensor may be regarded as the sum of symmetric and antisymmetric. So you're going to have C of ij being half C of ij plus C of ji plus half C of ij minus C of ji. And half of C of ij plus C of ji is S of ij. And half of C of ij minus C of ji is A of ij, where S of ij is symmetric, A of ij is antisymmetric. Numerous physical quantities have the properties of tensors of the second rank, so that the inertial properties of a rigid body can be described by the symmetric tensor of inertia. By the way of illustration, consider that we're given two vectors A and B. There are 9 products of a component of A and within a component of B. Okay, what's going on here? What is going on here? I don't understand. Yeah, this iPad doesn't even charge. Yeah. All right, so we already know the scalar. Yeah, mass is 100 kilograms. So one number, the book says the scalar is a tensor of rank 0. So one number, pretty much. Scalar means just one number. Now you already programmed the float of x, float of y, float of z. So in this case, we have a, b, c, x, y, and z, and we have pitch, roll, and yaw. So that's vector. Okay, again, don't focus on the word tensor. Just remember 3 numbers. So what comes after a vector? So the book now says tensor of rank 2. So it's simply a table of numbers. So for example, if I have C as 1, 2, 3, 4, 5, 6, 7, 8, 9, which is technically gamma of 1, 1, gamma of 1, 2, gamma of 1, 3, the authors are basically saying that matrix we're using, that's a tensor. So that rotation matrix is already a rank 2 tensor. I still don't understand. I still don't understand rank tensor. What is it? You just go to X and check what's going on. Now I'm gonna run behind this. Holy shit. Yellow light. Okay. Shit. Nope. People do give a shit about her. Like, I'm not good enough. You know what? That scares me. There you go. There you go. Actually, it does make a difference. The person who you- did he actually say that? Wait, let me see. APEC post. Okay, where is it? I don't see it though. That's the thing. I don't see it. Okay, I don't see it. That's okay. I don't see it though, right? Yeah, I don't see it. I don't. That's the thing. I don't see it. Right? I don't see it. Where do you even get that? That's photoshopped. Photoshopped. What do you mean white is better than yellow? No, yellow light is better. What? Please don't show strength here. It's your eyes, not muscle. White light isn't good. No, this is not some propaganda. I don't know man. I would rather be considered gay, but protect my eyes because I work with lights every day. I work with photonic lights than white light. I work with photonic lights every day. You're talking about white light when you have no clue what happens to your eyes. Calm down. I work with lights every day. Okay, tell me. Wait a minute. Tell me. What do I do? I can't. I can't. Wait, no, 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 no. Wait. I can't. I cannot. I cannot. Do you want me to illegally go out of the country? I can't. I can't. Ask me. Ask me. Ask me. Why I can't? Ask me. Why can't I? Why can't I randomly go back to India, even though I'm not from India? I'm not from India. From India. No, 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 no. No, 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 no. Let's see. What do they say? What do they say? Come on, you're so smart, right? Yeah, you're so fucking smart. Show your strength. Come on. No, 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 no. No, 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 no. Okay, I'm Indian. Okay, I'm Indian. All right, all right. I'm Indian. Cool. Why can't I go to India? Why can't I go to India? All right, come on, come on. Answer, answer, answer me. Come on, come on, come on, come on, come on. You're the best. You're the smartest. Come on, come on, come on, come on, come on, come on. Why can't I? Why can't I? Why can't I? Why can't I? No, 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 no. What? Then go to my workplace. Go to my workplace and say that. Go to my workplace and say that. I dare you. I dare you. I dare you. I dare you. Oh, you can't. You don't even know what I do. Even though my bio literally says everything, you don't even know what I do. What I do when my bio says everything. But okay, you're just ignorant. You're just ignorant. May Allah bless you. Hasbunallah wa ni'mal wakil. May Allah save you. No, 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 no. Go, 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 go. Go, 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 go. Go to my workplace and say, go, go, go. You don't even know what I do. You don't even know what I do. This dude. I like how they bark and now you're quiet. Go, 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 go. Go say that. Go. Anyways, what is the missile mass? But then I'm not sure about one thing. If you ask the missile mass is 100 kilograms, how many numbers do you see? One. So that's rank zero. Oh, so 3 by 3 is a rank two. So 3 by 3 is a rank two. 2 by 2 is a rank one. You know what? I'm also going to say one thing. What do you mean this was what? Built what? Built what by white people? What? Ya Allah. Built what? Okay, okay. What does built by white people have to do with supposedly having APEC money, and two, me, I don't know, going back to India. Allah is a God. God is literally Allah in Arabic. May Allah bless you. May Allah help you. Also, don't judge. Don't judge someone based on religion or nationality. I'm not Indian. I wasn't born in India. Raised in Qatar. If you believe Jesus is one true God, you do you. I believe Allah is one true God. I do me. Now, you said get out of the country. What do I do? Okay. No. What do I do? Like, what? Okay. No, no, no. If that. I work as a quantum computing researcher at my university. University. I have 9 scholarships, two dean's lists. I'm an author and the youngest teaching assistant for Department of Physics and Physical Oceanography. So pretty much, I teach white people. Now, do you want, because you're the only one that get out of America, whatever, would my students say the same thing? Actually, would my professor say the same thing? I want to see if he replies to this. Buy one for me, please. Buy one for me, please. Buy one for me. May Allah bless you. Anyways, let's move. Okay, but how do I program this, right? Okay, one question. How do you program this? How do you program this entire thing? How do you program this? Because I'm pretty confused. How do you program this? Let's say, how do you program this? So you did 2.1.3, 2.1.4, you're explaining, how do you program it? I want to see. I just want to see how do you program it? How do you program it? Okay, we got all the diagrams, we got all the angles, the yaw angle, the pitch angle, and all that stuff. How do you program it? I gave you the maths. Okay, I gave you the maths. I gave you the maths. How do you program it? How do you program the entire thing that closely correlates to my abstract? I want to see. I want to see. Yeah, don't worry about it. Don't worry about it. Then from this code here, can you add or modify the code? Just modify. Just modify. Don't explain anything yet. anything yet. Don't explain anything yet. Just modify the code. I'm hungry. Now you won't talk. I like how people say, "Oh my God, I'm this." People say, like, people feel the reach. Like, yeah, he's not Canadian. He's not Canadian. He's not American. He's not white. Dude, I don't care, man. I didn't come here to bark about religion. I have something else to worry about. But I hate the fact that when people say, "Oh, you're not white," but select all. I'm gonna move all this, remove it. What did you do? You got the position. You got the velocity. I know that's wrong, and the reason being is because that. Let me just quickly run it. I will just save it. File, file, save. And if I'm going to write gcc hello.main, hello main.c, sorry, hello main.c, oh, hello main, then there are 5 modules that plays a role here. You got the assigning the vectors and the position and whatever. You got the angles. You got the equation for the angles, and which means that in a case you actually call the function altitude, which has role, pitch, and yaw. If I were to write this in Python, then you're going to write define altitude, role, pitch, yaw, right? It's the same thing here, but then because this is in embedded C, so obviously you have to follow the program rules that closely correlate to embedded C. And then you got the altitude and stuff. One thing is that this is 0, 0, and 0. So be aware this is 0, 0, and 0, meaning sine the roll angle is 0, pitch angle is 0, yaw angle is 0. So it's like saying that if I were to move, I'm moving straight, literally straight. But obviously, in real life cases, you won't have full straight, right? I think chapter 2.2, they have equations and stuff. So I'm going to leave it as is and equate these equations are important. Now, these equations will come. I'm going to learn these equations now. I'm going to leave it as is. Actually, I'm going to leave it as is. Anything else I need to know? 0, 0 would be Cp times Cy. So Cp is the cosine for altitude roll. Cy. Cp, Cy, Cp, Sy, Cp. Why would it be Cp? These three. I don't understand what's going on here. I don't understand what is going on here. So C of 0 and 0. I know what Cp is. No, no. 0, 0. No, I know. Why did we pitch and yaw first? Oh, okay. The matrix is given. Is it given? No, it's not. But okay. Cosine theta, cosine phi, not phi, psi. Cosine theta, sine psi, minus sine theta. Ah, now I get it. Now I get it. Yeah, it's your eyes. It's not your muscle. It's spoken like a retard. Okay, no, that's not hard. That's not hard. Please. Yellow light helps. I'm speaking from experience. Forget about this spell. No, that's not going hard. That is not going hard. No, 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 exactly. Okay, why is white light better than yellow light? Explain. Explain. I've spoken like a tree retard. You're talking about white light when you have no clue what happens to your eyes. Calm down. Dude says white is better than no. You. Obviously, you won't explain it. No. Nah, man. Ah. Only when I thought you were good. Only when I thought you understood why you understood what's going on. Oh, come on. Why? Why, man? Come on. Nah, man. Yeah, I work with photonic lights every day. Okay, so this is the equation. So cosine of theta, cosine of psi, cosine of theta, sine of psi, minus sine theta, and then sine theta, cosine phi, cosine, sine theta, sine, fuck, sine phi, sine theta, cosine. I need to remember this goddamn fucking equation. Fuck this iPad, man. Okay, we're gonna remember this. Sorry, my iPad doesn't work. We have to remember this. I'll probably buy a new charger. So I have to remember this. The cosine of theta, cosine of psi, cosine of theta, sine of psi, minus sine theta. Because rest is all good. Rest is like, you can do the position, you can do the velocity, you can do the directional cosine, you can do the for loop and whatever. What does percentage 8.3f mean? Anyways. That's not the issue here. Issue is these. So I'm just going to put a comment here. Uh, directional cosine matrix. Cosine matrix from body to inertial frame. So this is important here. This is the most important one. Yeah, that's fine. Anyways, I'm just going to end it here. Then I'm going to do another stream.